guys, Tiny Maths here, back with another video, helping you improve at math one step at a time. In this lesson, you're going to be learning about equivalent fractions. By the end of the lesson, you will understand what equivalent fractions are, how to create them, and where they are used. So let's get straight into our lesson. Take a look at these two fractions. They have completely different numbers for denominators and numerators, but they are equivalent to each other. 16 over 25 equals 1120 over 1750. Equivalent fractions are fractions that appear different but have the same value. By the end of today's lesson, you will understand why these two fractions are equal to each other, why they are equivalent fractions. Now look at these shapes divided into sections. I've filled in sections of each shape with the colour green, representing a fraction of the whole shape. Here are the values next to each shape. So we have half, 2 quarters, 3/6 and 6 over 12. All of these fractions have different top and bottom numbers, but hopefully you can see that with each shape, half of it is filled in. So really, what we're looking at is fractions equivalent to 1/2. 1 is half of 2, 2 is half of 4, 3 is half of 6. And although the clock is a different shape, it's quite clear that 6 hours out of 12 represents half of the whole time. So all these fractions are equivalent to 1/2. Different numbers, but the fractions have the same value. To see what's going on, let's compare each fraction to 1/2. First, the numerator and the denominator of 1/2 have been doubled, and that gives the fraction 2 quarters. Now the numerator and the denominator of 1/2 have been multiplied by 3. The result gives 3 over 6. Then the numerator and denominator of 1 over 2, or half, has been multiplied by 6, giving 6 over 12. In all these cases, the numerator and the denominator has been multiplied by the same number. You could just as easily reverse the numbers, and then all you do is divide by the same number instead of multiplying, and that will give you the equivalent fraction. So all these fractions are equal, but why does this work? Well, it's because this technique exploits a mathematical fact which I'm assuming you are aware of, and that is any number divided by itself equals 1. How does that apply here? Well, take 2 over 2. 2 over 2 equals 1. If we multiply both denominator and numerator of half by the number 2, it is exactly the same as multiplying half by 2 over 2. And since 2 over 2 equals 1, that's the same as multiplying half by 1, and half times 1 equals half. The numbers of the fraction will change, but the value does not, because we are actually multiplying by 1. There's another thing going on too. In all of these fractions, the denominator is double the numerator. And that's what an equivalent fraction actually is. The numbers in the fraction might change, but the ratio between the numerator and the denominator remains the same. In every fraction here, the denominator is double the numerator, so we have equivalent fractions. Let's see how this works with that fraction we saw at the very beginning of the lesson. We said that 16 over 25 equals 1120 over 1750. So they are equivalent fractions, that's what we're claiming. That means that 16 times something equals 1120, and 25 times the same number must be 1750. Let's call that number A, and we can work out what A is by looking at the equation. 16 times A equals 1120. We say 16A equals 1120. To find A, we then divide both sides by 16, and that gives us that A equals 1120 over 16, which equals 70. So A equals 70. This means that the number which we multiply the numerator 16 and the denominator 25 by is 70. 16 times 70 equals 1120 and 25 times 70 equals 1750. We multiplied numerator and denominator by the same number, so these fractions must be equivalent. And of course, we can reverse the equation, and that would then give that 1120 over 1750 with top and bottom divided by 70 gives 16 over 25. Remember, 70 works because it is a common factor of 1120 and 1750, and you must use a common factor or common divisor to divide the numerator and denominator of a fraction if you want to maintain its value and get an equivalent fraction. So that's our basic set of rules for creating equivalent fractions. Either multiply both denominator and numerator by the same whole number, resulting in an equivalent fraction, or divide both numerator and denominator by a common factor of numerator and denominator, and that will result in an equivalent fraction. Here's a typical example where equivalent fractions are really useful. Look at this sum, 16 over 25 plus 2 over 10. Since the denominators of these two fractions are different, you cannot just add the two numerators like you would with similar fractions. You have to find a way to make the denominators equal to each other by changing the fractions up a bit. Once the denominators are the same, you can then just add the resulting numerators. You do this by replacing these fractions with their equivalent fractions. I could take 16 over 25 and multiply numerator and denominator by 2, and that gives 32 over 50. And we could take 2 over 10 and multiply numerator and denominator by 5, and that gives 10 over 50. Now, since 16 over 25 equals 32 over 50, and 2 over 10 equals 10 over 50, we can rewrite our original sum as 32 over 50 plus 10 over 50. And now, that's far easier to solve, because you can now add the two numerators. The fraction 32 over 50 has the same value as 16 over 25, and the fraction 2 over 10 has the same value as 10 over 50. So we just substituted the fractions for their equivalents, and because they have the same value, the new sum 32 over 50 plus 10 over 50 is exactly the same as the previous sum. Another place you'll use equivalent fractions is when simplifying or reducing fractions. We did that already actually. When we turned 1120 over 1750 into 16 over 25 by dividing numerator and denominator, we use the highest common factor or greatest common divisor of the numerator and denominator, 70, to divide them both. And that gave us an equivalent fraction, 16 over 25, which was a simplified version of 1120 over 1750. When simplifying fractions, you are simply reducing them to an equivalent fraction with the smallest possible numerator and denominator, and that's what 16 over 25 is, the simplified version of 1120 over 1750. If you're confused about these last two areas, I have made a couple of videos which I'll link to here so you can watch them and see equivalent fractions in action and learn how they are used in real scenarios. One of my most recent videos is about simplifying fractions, and the other is about how to add dissimilar fractions. I'll link them here on screen. Well, that's it for this lesson. Hopefully you understood the basic idea of what equivalent fractions are, how to create them, and where they are used. Thanks for watching. Take care. Until the next video.